Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about the functions of each and every layer in the OSI model. As already we know that there are 7 layers in the OSI model as shown here, which is the physical, data link, network, transport, session, presentation and application. We'll see about the physical layer. The physical layer coordinates the functions required to carry a bit stream over a physical medium. It deals with the mechanical and electrical specifications of the interface and transmission medium. It also defines the procedures and functions that physical devices and interfaces have to perform for transmission to occur. The figure shows the position of the physical layer with respect to the transmission medium and the data link layer. The physical layer is responsible for the movements of individual bit streams from one hop to the next. The physical layer is also concerned with the following functions. First one is physical characteristics of interfaces and medium. The physical layer defines the characteristics of the interface between the devices and the transmission medium. It also defines the type of the transmission medium. Next one is representation of bits. The physical layer data consists of a stream of bits, say sequence of zeros or ones with no interpretation. To be transmitted, bits must be encoded into signals, either electrical or optical. The physical layer defines the types of encoding. Next one is data rate. So data rate is nothing but the number of bits sent each second or duration of a bit. The transmission rate, the number of bits sent each second, is also defined by the physical layer. In other words, the physical layer defines the duration of a bit, which is how long it lasts. Next one is synchronization of bits. The sender and receiver not only must use the same bit rate but also must synchronize at the bit level. In other words, the sender and the receiver clocks must be synchronized. Next one is line configuration. The physical layer is concerned with the connection of devices to the media. In a point-to-point configuration, two devices are connected through a dedicated link. In a multi-point configuration, a link is shared among several devices. Next one is physical topology. The physical topology defines how the devices are connected to make a network. Devices can be connected by using a mesh topology, a star topology, a ring topology, a bus topology, or a hybrid topology. Next one is transmission mode. The physical layers also define the direction of transmission between the two devices. It can be either simplex, half duplex, or full duplex. In simplex, only one device can send, the other can only receive. The simplex mode is a one-way communication. In the half duplex, two devices can send and receive but not at the same time. In a full duplex mode, two devices can send and receive at the same time. So these are all the functions of the physical layer. Next one is the data link layer. So data link layer transforms the physical layer, a raw transmission facility, to a reliable link. It makes the physical layer appear error-free to the upper layer. The functions of the data link layer are: first one is framing. The data link layer divides the stream of bits received from the network layer into manageable data units called frames. These frames are reassembled at the receiver side. Next one is physical addressing. If frames are to be distributed to different systems on the network, the data link layer adds a header to the frame to define the sender or the receiver of the frame. If the frame is intended for a system outside the sender's network, the receiver address is the address of the device that connects the network to the next one. Next one is error control. The data link layer adds reliability to the physical layer by adding mechanisms to detect and retransmit damaged or lost frames. It is also uses a mechanism to recognize duplicate frames. Error control is normally achieved through trailer added to the end of the frame. Next one is flow control. If the rate at which the data are absorbed by the receiver is less than the rate at which the data are produced in the sender, the data link layer imposes a flow control mechanism to avoid overwhelming the receiver. Next one is access control. When two or more devices are connected to the same link, data link layer protocols are necessary to determine which device has control over the link at any given time. The figure shows the relationship of the data link layer to the network and physical layers. So header and trailer is added in the data link layer. The function of the trailer is error control. Next one is network layer. The network layer is responsible for source to destination delivery of a packet, possibly across multiple networks, whereas the data link layer oversees the delivery of the packet between two systems on the same network. The network layer ensures that each packet gets from its point of origin to its final destination. If two systems are connected to the same link, there is usually no need for a network layer. However, if two systems are attached to different networks with connecting devices between the networks, there is often a need for a network layer to accomplish source to destination delivery. The functions of network layers are logical addressing and routing. In logical addressing, the physical addressing implemented by the data link layer handles the addressing problem locally. If a packet passes the network boundary, we need another addressing system to help distinguish the source and destination systems. The network layer adds a header to the packet coming from the upper layer that, among other things, includes the logical addresses of the sender and receiver. Next one is routing. When independent networks or links are connected to create internetworks or a large network, the connecting devices like routers and switches route or switch the packet to their final destination. One of the functions of the network layer is to provide this mechanism. This figure shows the relationship of the network layer to the data link and transport layers. So network layer is responsible for the delivery of individual packets from the source host to the destination host. Hope you understood the functions of physical data link and network layer. In the next video, we'll see about the functions of the remaining 4 layers: transport, session, presentation and application. Let us take up few assessment questions. In the OSI model, a trailer is added to the data packet at which layer? Yes, it is at layer 2. The dash layer ensures reliable transmission on a single link. It's nothing but the data link layer. Transmission data rate is decided by the physical layer. Thank you for watching this video.